Okay, one last set of examples right here to help us out in dealing with these functions that involve properties of quadratic functions. In this case, let's do it again. We're asked to find the zeros of y equals x squared minus 2x plus 9, and let's put it in the context of the graph this time so we can see what's going on. All right, well, if we're asked to find the zeros, we could use any method that we like. I'm going to say, let's take our function x squared minus 2x plus 9, and let's set it equal to 0. To me, this looks like the kind of equation in which we could solve by completing the square. Let's try that. X squared minus 2x equals negative 9 if I move this over. And then, of course, we complete the square by adding half of x's coefficient squared to both sides. So I'm going to add 1 to the left and add 1 to the right. So I'm going to say negative 9 plus 1 over here. And so if I factor on my left, I'm going to get x minus 1 squared is equal to negative 8. Oh, interesting. Okay, so if I take the square root of both sides, what's going to happen? I'm going to get x is equal to positive and negative, the square root of negative 8, and we know there's no real number that makes that happen. What's the meaning of that? Well, let's take a look. If we add 1 to both sides, we get, and simplify our fraction, we get 1 plus or minus 2i times the square root of 2. Right? 1, interesting. Well, okay, what could we tell about this graph? First of all, if we get two complex numbers as roots, what it means is that there is no x-intercept. So wherever the vertex of this equation lies, it has to be the kind of parabola that will open away from the x-axis. Well, how could we find that? Well, let's go ahead and apply our formula right here. Remember, we said that 1 happens to be the location that we add or subtract to whatever we've got on the other side of this. So that should be the location of our x-coordinate of our vertex. So our vertex is going to be at the point where x is equal to 1. Let's see. If we put in 1 to our function, y will equal 1 squared minus 2 times 1 plus 9, which is to say 1 minus 2 plus 9 is going to give us 8. So 1, 8. So let's see, where's 1, 8 on our graph here? Let's try that out. 1, 8. And the a value, the value for a, is 1. So that means if we go to the left one, we should be able to go up 1. Will it go up 1? Yeah. And if we go to the right one, it'll go up 1. And our graph should pass through these points right here. So what does this look like? Well, sure enough, let's go ahead and try our hand at graphing here. Boom. Yeah, right? This is the kind of graph that it's not going to pass through the x-axis at all, but we could see that in this particular function right here, that we can get this idea right here that it opens upward. So if we know that there's no x-intercept, in fact, this is a useful tool. Solving for zeros can tell us whether it's worth finding those x-intercepts. And one thing I might point out is that if we use our quadratic formula right here in this function, we're going to find that we're going to get a square root of a negative. So we can actually use the discriminant of our quadratic formula to tell us whether or not we're going to have x-intercepts to find in the first place. How do we do that? Well, remember the discriminant in our formula is b squared minus 4ac. It's the quantity that occurs under the square root. All right, so what have we got here? If I said y equals 2x squared minus x minus 1, how many x-intercepts? Well, if a is equal to 2, b is equal to negative 1, and c is equal to negative 1, then substitution into our discriminant is going to give us negative 1 squared minus 4 times 2 times negative 1, which is the same as saying 1 plus 8, or 9. So there will be 2 x-intercepts here. Right? And if we really wanted to, it would be worth our time to find those. How about g of x over here? Will g of x have any intercepts? Let's check it out. A, that's equal to 1. B, that's equal to 1. C is equal to 2. So substitution into our discriminant gives us 1 squared minus 4 times 1 times 2, which is to say 1 minus 8, which is negative 7. So in this particular case, without even doing a whole lot of work, we've come across a parabola that has no x-intercepts. Okay, well that's it then. Good luck on your homework. Let me know if you have any questions.